were coming up with the probability of passing exactly 1, and I needed to add up these 4 terms in my sum. I entered that all into my calculator, and the probability is 0.132. So I'm just going to write that, 0.132, and that is the answer to number 1C. I'm going to flip this over, so I'll just write 0.132. All right, is that a 132? Yes, that's enough. The next question is addressing the tree in a different way. What's the probability that a student passes at least one of the 4 quizzes? I want to pass at least one, so let me go back to the tree. At least one. Yep, 4 is at least 1. Man, there are a lot of different branches, and I would have to multiply all the way through, pass and pass and pass and pass, and each one of these paths are acceptable. Pass at least one. Pass at least one. All except this guy at the end. This is the only scenario where I don't pass at least one. That's only calculating the probability of passing none. So let's do that. The complement of at least one is none. So if I want the probability that I pass at least one, I'm going to use the complement rule and find the probability that I pass none. And then I only have to calculate the probability that I pass none, in other words, fail all of them. 0.3, and I fail another, and I fail another, and I fail the 4th. So it's the product of 0.3 times 0.4 times 0.5 times 0.6. So 1 minus the probability I pass none, I fail them all, and this is 0.3 times 0.4 times 0.5 times 0.6. Just quickly getting that in the calculator, I'm going to say 1 minus 0.3 times 0.4 times 0.5 times 0.6. The likelihood that I pass at least one is 0.964. So that is 0.964. Just for fun, what was that sum? Let's see. Let's take away 1. And so I was subtracting off, can you see that? 0.036. That's the probability of passing none. I'm going to use that later too, so I'm going to write down the probability pass 0. And we ended up with 0.036.